To find the moment of inertia of the circular disk about the axis through the center of the disk and perpendicular to its plane, first we will suppose that disk is composed of the elementary rings. Then we will find the moment of inertia of the elementary ring about the same axis, and then we'll integrate to find the moment of inertia of the disk. So first we draw the disk, and suppose it is having the mass m and it is having the radius r. The mass is distributed all over its area. Therefore, we define a term sigma. This is the area mass density, and this is the total mass is m, and area of the circular surface will be pi r square. Now we can think that there is a elementary ring of radius say small r of thickness dr. So first we will find the area of this elementary ring and then mass of the elementary ring. So we can say that area of elementary ring is equal to 2 pi r, this is the circumference, into thickness. So area will be 2 pi r dr. So elementary mass will be equal to mass density sigma into area, that is 2 pi r into dr. Now mass is distributed in a symmetrical manner all over this area. Therefore we will use the integral method to find the moment of inertia. So I will be equal to integral dm into r square. This is the formula for continuous mass distribution, and it will be equal to integral dm is sigma into 2 pi r into dr and into r square. So it will be equal to integral, replacing the sigma, it is m by pi r square into 2 pi into r dr into r square. Now constant terms will be taken out. First pi get cancelled and constant terms are taken out of integral. It is m by r square into 2, and remaining is integral r cube dr. Here we will integrate from r equal to 0. That means initially the lower limit will be the point circle, this is r equal to 0, and finally the upper limit will be r equal to capital R. So it will be equal to 2m by r square into integral of r cube is r raised to power 4 by 4, lower limit is 0 and upper limit is r equal to capital R. So it is equal to 2m by r square into first upper limit, it is r raised to power 4 by 4, minus lower limit, it is 0. Therefore we get 2m by r square into r raised to power 4 by 4, and this will give this 2 get cancelled, so it is 2, r square get cancelled, it is r square, so it is half m r square. Therefore moment of inertia of the circular disk about the axis passing through center and the perpendicular to the plane of the disk is half m r square. We get different cases. Say case 1, if we consider a point, say there is a point on the circumference, say this is point A, and we have taken the axis which is perpendicular to the plane of the ring disk, then we can find that moment of inertia about A by the parallel axis theorem will be I plus total mass of the disk into distance between parallel axes, and this distance is r square. So it will be equal to half m r square plus m r square, and it will be equal to 3 by 2 m r square. In case 2, if we consider a diameter, so moment of inertia about diameter, as we have done in the ring, we will consider two axes which are perpendicular. One is x-axis, another is y-axis. These axes are in plane of the disk, and we can write that this I diameter is equal to Ix and it is equal to Iy. And using the perpendicular axis theorem, we can write that Iz is through the center of the disk and perpendicular to the plane of the disk. it is equal to Ix plus Iy, and we can write it as 2I diameter. Therefore, moment of inertia about diameter will be equal to half of Iz, and Iz we have calculated half mr square, so it is half into half mr square, and it is equal to 1 by 4 mr square. Similarly, we can take another case, that is the tangent. So moment of inertia about tangent. We can take tangent through the point, say A. This tangent is parallel to the diameter, so we can write from the parallel axis theorem that I tangent equal to I diameter plus mr square, where m is the mass of the disk and r is the radius or the distance between these two parallel axes. So we can write it as 1 by 4 mr square plus mr square. So it is equal to 5 by 4 mr square. Let's take some problems.